Data management is becoming an increasingly important part of the work of restoration professionals, from project design through the data lifecycle to the release of data. Good data management practices will increase the likelihood that conclusions are evidence-based. They also allow others to feel confident in the quality of the data and the research conclusions and management decisions made from them. Federal case managers and their collaborators are expected to meet requirements of the 2018 Geospatial Data Act, the 2018 Foundations for Evidence-Based Policymaking Act, and the Open, Public, Electronic, and Necessary Government Data Act of 2019 as they prepare and share data and metadata with the public. Although there may be exceptions, restoration practitioners should assume that the data will be made public and will need to meet these requirements. Case managers should refer to their bureau's data management policy and assigned case solicitors to ensure compliance with these laws. Becoming familiar with data management standards can feel overwhelming. Let's start with the basics so you can feel confident setting your project up for success. After watching this video, you should be able to recognize what an effective data management plan looks like in the context of restoration, monitoring, and citizen science. Learn about the USGS Data Management Plan checklist, where to find it, and how to apply it to your project. Identify at least 3 useful existing citizen science and/or restoration data management tools. Know where to find additional information that builds on this video series. Although there are many possible tools for developing a data management plan, the U.S. Geological Survey, or USGS, has developed a model that identifies key elements to consider for a good data management plan. Step 1. Plan. Who will collect the data? When will it be collected? And what are the restoration areas? Step 2. Acquire. What sources and methods are used to collect or acquire the data? Step 3. Process and analyze. How do you plan to transform and summarize the data? Step 4. Preserve. How and where will data be preserved during data collection and analysis? Step 5. Publish and share. How will data be made available to potential users, including data formats and online sources? Step 6. Describe. Creation of metadata describing the source, methods, and quality of data. Step 7. Manage quality. How will you ensure and document data quality? And Step 8. Backup and secure the data. How will you back up and secure your data during data collection and processing steps? If you are able to provide information relating to each portion of the checklist, you have most of the elements of a good data management plan. You can deep dive into each of these steps of the USGS Data Management website. There you can find the checklist as well as tools and templates for developing a data management plan. Many other sources provide tools and templates that may be more useful and appropriate for your citizen science project. Take a moment to pause the video and explore the USGS Data Management Plan checklist and the other resources available. You can look at it in detail now or come back to it after the video. You may be wondering how all this data management planning relates to the citizen science portion of your restoration project. The short answer is that data management planning is just as important for the citizen science part of your restoration work as it is for the rest of the project. Citizenscience.gov includes a project planning toolkit. Step 4 of the toolkit covers managing your data. You'll find that the data management steps here very closely mimic those the USGS provides. Consider a few additional topics to think about, like obtaining permissions from volunteers for potential future uses of the data, and making data policies, terms, and conditions available to participants in plain language. Also consider consulting with a NRDAR case attorney to ensure you're informed about agency data management requirements and potential data sharing restrictions. It is well worth a few minutes of time to review the Manage Your Data section of the citizenscience.gov toolkit to make sure you cover all the important pieces of data management for the citizen science portions of your restoration project. Finally, there are a number of existing databases available for storing and visualizing restoration data collected by the public and for their use. The Damage Assessment and Restoration Tracking System, or DARTS, database includes case files and data, restoration management plans, and additional documentation about NRDAR projects. Attaching a data management plan to your restoration and monitoring plans may be a preferred practice for your projects. Citizen science platforms such as citizenscience.org, eBird, iNaturalist, and the Natural Phenology Network may include data collected by the public for restoration monitoring at NRDAR project sites. For example, a restoration team working on the Jordan River in Utah worked with the citizenscience.org platform to create a hub page for the project, describing the restoration work and showcasing monitoring data collected by project partners. This hub page provides a shared space for partners and the public to continue to and share the ongoing story of the Jordan River restoration. This story will be able to continue even after the NRDAR case team has completed case closure. One final note. Over 100 members of the participatory sciences community co-created a data ethics toolkit to provide practitioners with resources for considering ethical issues around data in participatory science. Download the toolkit at citizenscience.org. In the next video, we'll talk about how you can develop a framework for implementing your project that establishes clear roles and responsibilities for everyone involved and helps you think through the project timelines that work well for restoration projects. For more information about this video series, visit doi.gov/restoration.